Okay, so we have a really awesome project that we're starting pretty much right now. I'm going to cut another tool path of my ceiling tile project that you may have seen. So a customer called and said, I need a Hager 31J pull. A 31J is a flat profile pull, 10-inch center to center, and it'll be down onto a 4x16 push plate. No big deal. And the manufacturer doesn't have it in stock. And as I was taught when I was 16 by my grandfather, he would say, you know, a customer's going to come in, he's going to ask for something, and you're not going to have what he's asked for. And he said, well, sometimes that's okay in the sense that you want to offer the client what you do have. You always want to take that sort of encounter and at least offer something that you can supply. And the experience that he gave me was very important. Literally, we mocked a customer walking in, a very large Chicago contractor, definitely still in business today. And I was able to use what he had taught me on this customer, and I'll tell you, it worked the very first time I did it. The customer walks in and says, I need a saddle threshold, or I need a interlocking threshold that's this by this. And you know in your head, well, that may not exist. So the tactic that you employ is you take out the catalog and you can flip through the pages. But what my grandfather taught me was invite the client to come back to your area of the warehouse where you stock thresholds, and then you begin showing the client all the different thresholds you have. And sure enough, when the client is faced with, we don't have it, however, you can leave right now with this. We don't have exactly what you want, but a threshold is a threshold is a threshold, not exactly. But when you show them what they can walk out with, what you don't know, because you don't know, is the client, in many instances, can make many things work. And it's salvaged the job. So, this client calls for some Hager 31J pull handles. This is a movie studio. This is a movie studio that everyone has heard of, period. Hager 31J needs 4 of them, not in stock. It's a 1-inch wide, square profile, 10-inch center to center. Well, falling back on what I was taught 40 plus years ago, I showed the client what we did have. We didn't have a 31J, but Ives, the 8305-0 is in stock. 10 center to center, but was the 1-inch diameter round bar. Client says, I gotta have the square bar. Went back to the client, well, we have the 8301, I think it's an 8301 or 8302 Ives, square profile, but 6-inch center to center. Client says, well, that's nice, but it has to be the 10-inch. I said, well, I can make it for you on the CNC machine. He says, yeah, send me a quote. So, needless to say, we got the job. I'm gonna turn this 1-inch solid block of 6061 8-inch by 12-inch into 4 individual pull handles, and that's what this video is about. And I hope you'll watch as we go through the journey. Unscripted drama is guaranteed. Success, not so much, but fingers crossed. Let's move on. So the first thing we're going to do is we're going to surface the table because I've got a little bit too much happening here in terms of depth for my liking. So where I'm going to fixture that piece of aluminum will be in zone 1. And I've got a cut here that's pretty deep that I just don't want to bleed any air more than necessary. So we're going to surface the spoil board, and then we're going to come back and get this set up the way that it needs to be set up so that we can fixture this really giant piece of aluminum down as best as possible. So let's move on. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, so let's take a look at the file that I've created in vCarve, and this is the uh, surfacing of the table that I did. I'm going to save this in my directory for this project. Let's open up our file. Let's take a peek at it. It's been a solid week since I've looked at the file that I've created. So at this point, we're going to do a verification of what I've done. So what we're seeing here is, okay, what we're seeing here is, right on. Okay, so I had to refresh my memory. So what we have are the parts nested. We have our hold down and our border. Right on. Okay, so here are the 4 pull handles that we're going to achieve out of this piece of aluminum that I have. I haven't put a caliper on that piece of aluminum yet, so let's just take a look. Pull 1, 2, 3, and 4. I've got 4 door pulls I'm going to make. A profile cut, profile 4. Okay, yeah, okay. Profile 4, we're going to rename that to hold down raceway. I'm going to call it. Oop. So let's look at our 4 pulls. Let's take a look and see what I'm trying to get to on this. Let's preview the selected tool paths. We've got that moving as quickly as it'll go, and the problem is it's aluminum, and my pass depths, I believe, are a 1/16 of an inch. And I'm probably going to make them even shallower, but we'll see. That means I'm going to make 17 passes through this material, because 1 inch is 16/16 of an inch passes, and a 17th pass. So I'm just going to let this run. Last pass on that first pull, and apparently all it did was the first pull. So let's preview visible. Here's the second pull. And I'll just let that run. Now, it's going to take a minute and a half or so. So we're almost done with the second pull. It's nice that we can manipulate this while it's cutting. So you can see my idea. I'm using the 1/4 inch bit, I believe it's a 1/4 inch, to give me both um, give me all the cuts that are really needed. So the front side of pull 2 is going to be the back side of pull 3. And that's the idea. So I'm trying to maximize efficiency with what I'm cutting. Slow that down, and we'll see the bit come down here, but I've already cut that material. Okay. It it didn't have anything to cut, so I think it just shot down. That's where we're ramping. Yeah, it just shoots down when it's not cutting anything, so we'll speed that up again. This is pull 3. Almost done with pull 3. There we go. Pull 3 is done. Now we're starting pull 4. And I just nested the material, so I'm trying to be as efficient as possible. I don't know if it's going to work in practicality, but I'm sure hoping it will.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
And then I'll show you what the other tool paths were for, and what my initial idea is. Okay, last pass there on that. Okay, now double click on the items that you want to get rid of, the artifacts that are cut off. There are our 4 pull handles, and this is what I'm shooting for. This is what I'm aiming for. Then what I'll have to do is I'll have to drill and tap the mounting bolt holes into the back of these pulls. 1 inch wide, and I think this dimension is 3/4. Wait a minute. Yeah, you can just check that. Let's check that. Yeah, 3/4 inch. So these poles are going to be 3/4 thick, 1 inch wide. They're going to be 10-inch center to center, 10-inch from here to here. Solid 6061 aluminum. Now the other parts that the other tool paths, I should say, was hold down and X was hold down. So let's go back here. So what I'm planning on doing here is superimposed are these hold down raceways. So I'm going to have these raceways underneath the area of each pull handle. I'm going to drill these holes through the material that the aluminum is going to sit onto. So let me back up. These raceways, I'm calling them, and these holes are going to be milled into a piece of 1/2 inch polycarbonate. The raceways will be, let's say, 1/4 inch or 5/16 deep. The holes will go through the 1/2 inch. The aluminum will then sit on, squared off to my XY border corner datum here. So on top of my spoil board, I'm going to place the 1/2 inch polycarbonate. On top of the 1/2 inch polycarbonate, I'm going to place my block of aluminum. My zone 1 of my vacuum table will be the only zone turned on, and that will occupy the area where my work will sit. Because I'm using polycarbonate, I will have 0 leakage through it. And I'm hoping that my vacuum is going to be able to hold the piece down without tabs. That's what I'm going after. Let's take a look at the raceway. Reset the preview. Preview selected. Nope. Oh, sorry. I had preview 1 selected, or pull 1 selected. Hold down raceway. Why is it doing that? Those are my hold down raceways. And I'm going whatever depth. Let's go, let's add our drill. These holes are going to go through the material. They don't show going through because I have them put onto this model. When I switch that thickness to breaching through only the polycarbonate, we'll know. My XY border will be important because XY border will be important so that I know where to position the aluminum onto the piece. So I'm just going to very lightly score the polycarbonate with that. So if we select our poles, we can see that our superposition covers all of that.
That's the plan. Now what I need to do is tighten up um, my work on this. Uh, and what that means is on the hold down raceway, I'm using a 1/4 inch end mill. I'm going to go in on my raceway. I've got it at a 1/4 inch. I'm just going to change that to 5/16. Fine. Hold down raceway, calculate. My drill, I'm going to go in 0.55. So I'm going to get into the workpiece 50 thousandths deeper than what the polycarbonate will be if it's 1/2 inch. I've not measured it yet, so I have to tweak that. My scoring, my XY border, I don't know what I've done on that. 50 thousandths with a 1/16 of an inch end mill. And apparently all I'm going to do is stay right to the line and just score that. Let's take a look. And I'm going to shift everything over because well, let me just show you what I mean.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
So I'm going to shift all the work over because if I'm using this as my datum, that's fine and dandy. My bit is going to be right here. The issue is I've got several inches from the center line of my bit to where my dust collector is working. So my dust collector is literally hanging off here, and all the aluminum is going to end up down on the ground. So I'm going to shift my workpiece over, pretty much whatever I've got it sitting at here. No reason to guess. Just do it right now. So, yeah, I'm going to move it 12 inches off, 12 inches over. So I'm going to be 12-inch clear, and I'm going to be able to pick up all of that material that's going to fall off the table. And in fact, I'm going to shift it up off of the, I'll shift it up on the y-axis, 6 inch. So just keeping round numbers, I'm going to increase my width by 12 and my height by 6. I'm going to kick the workpiece up and over is what I want to do. I know there's other ways to do it, but this is just the way I'm going to do it at this time.
Okay, so let's make our width 12 inches larger. Delete. Okay. 19.5, and then we're going to scooch it up 6, is what we said. So that would make it 18, because it was 12. That'd probably be a good datum position, actually, for the work. Yeah, we're good. We'll leave it. Okay. Yeah, it's all good. Now, what I want to do, 2D view, I want to bring a guideline to 12 inch. I want to bring a guideline to 6 inch. 6, and 12. Got it. This is going to be my new point right here. Let's get rid of the guidelines. Let's turn everything on. Let's grab all of it. Let's move. That should have done what we wanted it to do. Now, that lower right-hand corner should be at that intersection. Yeah, we're good. That was our guidelines. That's where we wanted that workpiece. So now we've got it set such that the polycarbonate is going to serve to give us a really good seal. The piece is going to sit on top of that. And if my vacuum pumps and this design is going to work, then we're in good shape. The only thing that I've not said that I'm going to do is I'm going to put a piece of 1/4-inch MDF down on top of my spoil board because I'm going to be using lubricant, and I do not want the lubricant to spoil my spoil board, which could then get ultimately pulled into my Becker pumps. And while pulling the moisture through my 1/4-inch buffer between my spoil board and the underside of the polycarbonate, I'm expecting that that's an adequate amount of barrier is what I'm trying to say. So at this point, I'm going to go around the shop and collect all my parts. I'm going to go through my startup routine on the CNC, and I'm going to start to air cut the polycarbonate in the sense of giving me my XY, scribing my XY so I know where to place my aluminum. Sure, I could measure it, not the end of the world. Scribing that, and then doing my raceways and drilling my holes. So I'm going to check back in with you when I've made some progress.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so let's go over the quality of cut. I started off, I will admit, somewhat absent-mindedly with a 1/4-inch down cut, 2-foot down cut, and the 3 passes, the material liquefied inside. That's all hard and rigid. I can't pull that out. And I then said, well, I realized that the down cut was the problem. I switched me to a single O upcut. That's an Amana bit. This is an on-groove. Doesn't really matter. The bottom line is reran it and got a beautiful, beautiful cut out of that. 18,000 RPM on that. About 10,000 RPM on that. Chip load 0.006 on this cut, 2 inches per second. Really happy with that cut. The interesting thing though is it looks like it's 2 feet. It should be 5/16. Let's get the caliper and check that. Yeah, it's right on the money. It's right on the money. It just looks like it's too deep. Put that away. Let's bring our tool back home and recut this. Diameter, 1 flute, 18,000 RPM, 0.067 chip load. Let's rerun that. So I'm going to pause that so I can get some local dust collection going on it and just recut it and move to my next tool path.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.